These are the frequently asked questions for Algebra 2 for section 1-1. This is the video that got eaten either by my computer or by YouTube when I was downloading it, and it is gone. So let's take a peek at this. For number 15, that'll be the first one that I'm doing here for an FAQ. It says, make a table with a process column to represent each pattern and write an expression for the number of tiles or circles in the nth figure. So for 15, what we want to do is just get started by simply thinking, okay, this is the first figure, second, third, fourth, and counting the dots. This has 3. Well, the second figure had 3, but now they've added 4 more, so that's 7. And you'll notice with each one of these, it's going up by 4 each time when you count it. So you hope that you'll be able to figure out using an input, output, and process column what's going on. So the input is first figure, second, third, and fourth figure. And we noticed that the outputs were 3, 7, 11, and 15. And each time here, we were going up by 4. Now, some people noticed and actually asked me about it. They said, you know, we were talking about how when the numbers go up, maybe it's addition. So we'd start there and say for the process column, maybe it's +2. But you get to the second one and you realize, well, while 1 plus 2 may be 3, 2 plus 2 is not 7. So that's not going to work. And then you say, all right, well, maybe I'll try multiplication. And you start with 2n, because that would be the first number we would think of multiplying by that would be easy to do. And you'd say, okay, 1 times 2 is 2, and I would have to add 1 to get 3. So the formula that I really want to do is 2 times n plus 1. But you go down to the second figure and you put a 2 into this formula and you only get 5 and you realize it doesn't work. So you keep going with 3 and you get to 4 and you find out it's a 4n formula. So 4 times 1 would be 4, and I would have to subtract 1 in order to get the output of 3. So then we go to the second number and we say, all right, well, this is going to work if I put a 2 in there. Well, 4 times 2 is 8, and 8 minus 1 is 7. How about the 3? Let's put a 3 in there. 4 times 3 is 12. 12 minus 1 is 11. Ooh, we may have found it. Let's try the 4. 4 times 4 is 16, and 16 minus 1 is 15. So this is 4n minus 1. And like I said, some people had come in before school and after and said, well, if you see that it's going up by 4, can you just use 4n, jump to 4n right away? Well, if the relationship is linear, the answer is yes. So know that this isn't always going to work, but if the relationship would be graphed on a line, then the answer is absolutely. You can just kind of jump to that and skip that part. All right, next one on the list that people will usually want to see would be something like number 21. So in number 21, it says identify a pattern by making a table including that process column. So we're again at input, process, and output. But this is a little different, and that's because it's like a set of coordinates. You know, the first point that we see here is at 1, 0. Well, the input is 1, but the output is 0. And then we have 2, 1, 3, 2, 4, 3, and 5, 4. And now maybe you look at those outputs there and you say, well, it's going up by 1 every time. Or you say, yeah, you know, it definitely went down and then it went up, you know, so how do I write what's gone on with this? And what we would do is we'd give it a try and we'd say, all right, if it's going up by 1, that's going to be 1n. So if I put a 1 into this formula, right now I'll have a 1, but I need my output to be 0. So I would have to subtract 1 to get that number. And then I check to see, does that work for all the rest of them? 2 minus 1 is 1. 3 minus 1 is 2. 4 minus 1 is 3. And 5 minus 1 is 4. It is working. So that n minus 1 is definitely going to be the pattern that we identify. And said identify it by making a table, include a process column. We have it. Always going back and reading the directions afterwards to make sure that I've answered everything that they need me to answer. And nobody had a question about those, but number 26, these problems down here occasionally can give somebody trouble. Identify a pattern and find the next three numbers in the pattern. Notice it doesn't say we have to come up with a formula. It says identify the pattern. So I see the numbers are going up, and that means I should try addition. And I see that it's adding 3, but then, wait a minute, that one doesn't go up. They subtract 1. And at first I think, well, maybe that's not the pattern I want. But now look at the next one. 3 to 6, they're adding 3 again. And then 6 to 5, they're subtracting 1 again. That is the pattern. So that's what I have to talk about. That's what I have to identify. So we'll say, starting with the number 1, add 3, then subtract 1, and continue the pattern. That's what we're doing. We're adding 3, then subtracting 1, adding 3, and subtracting 1. So the next three terms, well, we just got done subtracting 1, so the next thing we would have to do is add 3 to 5, and that would give us 8. Then we'd have to subtract 1, and that would give us 7. And then we'd have to add 3, and that would give us 10. So 8, 7, and 10 would be the next three numbers in the pattern. Next up, we've got number 31. And number 31 says identify a pattern and draw the next three figures in the pattern, and they give us these over here. Okay, so the first thing I would do is, if you're having trouble seeing this one, I would copy it on my paper because it helps that you have to make the blocks and then you have to figure out how they've changed to get to the next spot. So in the first one, the dot is here. In the second one, the dot is here. So right now I'm thinking, oh, cool, you know, it's just moving it one to the left. But I'm going to be able to check that by using the little red block. So the little red block was here. Now the little red block is here. Well, doggone it, that moved it to the right. But it's still going in this direction, and that direction is clockwise. So for identify the pattern in number 31, they are moving the blocks one clockwise position. And we can certainly see that that pattern is going to continue with the third one. So then our job is the next three of them. And I would just go ahead and make the blocks. Oops, need another one there. There we go. And then notice, all right, if I continue clockwise, then the little dot's going to go there, and the little block will go there. Then this little dot will have to go here, and this little block will have to go here. And then this little dot will have to go there, and this little block will have to go there. It's a clockwise motion that we see for those. 32. Write a rule so that for every input, the output is an even number. And I think, okay, well, what can I do to any number that will make it even? So that it'll end in 0, 2, 4, 6, 8. Oh, wait, I could just multiply it by 2. There's a rule. Really, this works when you multiply it times any even number. So you could do 2n, 4n, 6n, 8n. When we multiply by that even number, we are going to get an even number back. But the easiest one, obviously, would be just 2n. All right, number 33, think about a plan. A moving company sells different sizes of boxes as shown. The extra large box is one size larger than the third box that we see. What is its volume? Volume is of a box is length times width times height. So what I need to do is figure out what on earth the pattern is and increase those numbers appropriately. So 12, 16, 12, 16, 16, 16, 20, 16, 20. First thing I noticed was the 16's not going anywhere. So I need to keep that. And then I look from 12 to 16, 16 to 20, 12 to 16, 16 to 20. And I think, well, they're going up, so I'm going to try adding. They'd have to add 4. 12 plus 4 gives you 16. 16 plus 4 gives you 20. So that means those other two dimensions that I need, I have to add 4. Well, I have 20. Now it's going to be 24 inches. And it'll be 24 inches in 2 spots. Actually, I should put my 16 down here, shouldn't I? And to find the volume, we need to multiply all those together. So 24 times 16 times 24. And that will give me 9,216 cubic inches. So there is 33. Sometimes people just forget that formula, length times width times height. 35 says Jay has a rare baseball card collection. He currently owns 10 baseball cards. Each month he purchases a new card. Well, a new card means one new card for his collection. Write a model to represent the number of cards in Jay's collection after n months. All right, so right now he has n cards. In 1 month, he'll have n plus 1 because remember, he adds one new one every month. And then n plus 2, n plus 3. But this formula right here will tell somebody what he'll have after the first month. And once they find the first month, they can just keep adding 1 and keep going. So this would be an easy way to show that, hey, he's purchasing a new card every month, and you've got it. 36, use the figures below. Draw the next two figures. Oh boy, all right. Well, you'll notice as you go through this, it had 1, and now they've added 3, and now they've added a new row of 5. So what they're really doing is they're stacking these blocks, but they're always making sure that there's another block on either side of the central block, and they're adding a new one every time. So they add a new one out here, put the old ones back on, add a new one out there. So the next one would look like so. And the next one after that, continuing on with A because they wanted the next two figures, we just keep building. Whew, got it. Draw the next two figures. There they are. And then it says copy and complete the table to find the number of squares in each figure. Okay, well there's 1 here. There's 4 here. Then they added that row of 5 down at the bottom, so that was 9 right there. Then they added a row of 7, and that was 16. And then we have to add this row down here, and that would be adding 9. So our outputs, 1, 4, 9, 16, 25. And then it says, what is the number of squares in the nth figure? So basically they want us to use that process column to figure out what's going on. And hopefully you recognize the 1, 4, 9, 16, and 25. I know it's been a little while since you've talked about powers, but those are the perfect squares. So n squared would be the answer to the number of squares in the nth figure. And it says explain your reasoning. Well, you'd say 1 squared equals 1, 2 squared equals 4, 3 squared equals 9, 4 squared equals 16, and 5 squared equals 25. These are the perfect squares. That is an excellent explanation. Let's see if there's anything down here. Oh yes, we've got a couple of them. Copy and complete each table. All right. So basically what they're doing is they're doing the, copy the table down, think about that process column so that you can come up with a rule to put in here for n. And again, when they're linear, what we can do is just check and see, hey, that's up by 4, that's up by 4, that's up by 4. So it should be 4n something. So let's look at it. If we put a 1 in, 4 times 1 will be 4, and I'm going to need to add 1 to get 5. Let's check the 2. If we put a 2 in, 4 times 2 is 8. 8 plus 1 is 9. Beautiful. Let's check the 3. 4 times 3 is 12. 12 plus 1 is 13. One more to check. Let's try a 4. 4 times 4 is 16. Plus 1 is 17. That is our rule. 4n plus 1. Number 38, same type of thinking. We take a look at this and say, we would have to subtract 5 each time because these numbers are definitely going down. So maybe it's a negative 5 and something. Well, let's take a 1 and put it in here. Negative 5 times 1. I would get negative 5. How am I going to get that to be a 2? I'm going to have to add 7. That would make it work. Let's try a 2. 2 times negative 5 is negative 10. Negative 10 plus 7 is negative 3. It's working. Let's try a 3. Negative 5 times 3 is negative 15. Plus 7 is negative 8. Negative 5 times 4 is negative 20. Plus 7 is negative 13. And we have found it. Like I said, it works for those linear relationships. If when we graph these points, these will all graph on a line, then that process is going to work. Number 43 says, which of the following is the best statement about the graph? Well, obviously we want one that's true then, if it says the best statement. After 4 weeks, the plant will be 7 inches tall. 4 weeks, 7 inches tall? No, that's 6. The plant was 1 inch at the beginning of the experiment. Liar, liar, pants on fire. That's a 2. No. After 2 weeks, the plant will be 3 inches tall. No, it's 4. Process of elimination, it has to be D, but let's see if it'll fit. After 6 weeks, 4, 5. Well, how am I supposed to know? There isn't even anything there. Well, I'll use the pattern. We're going up 1 and over 1, up 1 and over 1, up 1 and over 1, 7, 8. Bingo! There it is. So if we extend that pattern, we'll see it. 44 says, which is the 7th number in this pattern? Well, let's see. They're going up, so let's try adding. Here they're adding 5. 13 to 18, they're adding 5. 18 to 23, they're adding 5. So let's keep adding 5. 23 plus 5 is 28. 28 plus 5 is 33. 33 plus 5 is 38. They wanted the 7th one. 1, 2, 3, 4, 5, 6, 7. Bingo. There it is. H is 38. Number 45 says, look at the pattern shown. 144, 72, 36. All right. Well, if you didn't notice right away, what you'd want to do is say, subtraction, is that going to work? Well, let's see. 144, I'd have to subtract 72, but 72 minus 72 is not 36. Maybe it's division. Well, 144 divided by 2 gives you 72. 72 divided by 2 is 36. There it is. Divide by 2. So it says for the rule part, what is the rule for the pattern? N over 2. N divided by 2. Well, that kind of doesn't look like a 2. I better put this over here. Make it a little bigger so it looks like a 2. B says, what is the first non-integer number? So the first one that would give you a decimal or a fraction. Well, let's see. 36 is the last one they have. 36 divided by 2 is 18. 18 divided by 2 is 9. 9 divided by 2, ooh, that's 4.5. That is it. That's going to be, and you certainly could put 9/2 as your answer too. In fact, I would prefer that instead of the decimal. So 9/2 would be the first one that we would have that would be a fractional answer there. Then for the last portion, for number 56, these say to prepare for lesson 1-2, we need to know how to write each one of these numbers as a percent. Well, to write numbers as a percent, you move the decimal 2 places to the right. So 1.72 is 172%. And that is what we needed to have. So let's see. If you forgot how to do that, how could I help you out with that? We have to have 1 and 72 1/100ths. And what we want to see is what is that as a percentage. So what we would have to do is change this into something over 100. So we would multiply by 1 and then add 72, and it would be 172 out of 100. Since 100 is what we use for percentages, everything's out of 100, this will give you 172%. And that is the last one for the FAQs.